Today's video is about inverse functions. So let's start with the definition. The basic idea behind an inverse function is that it's a function that reverses another function. So I'll explain what I mean. I'll give some examples. For example, if you have f of x equals x plus 3, its inverse is actually something like g of x equals x minus 3. Also, if you have something like f of x equals x squared, the inverse of squaring something is the square root, so the inverse of that one would be the square root of x. Similarly, if you have like 3 times x, the inverse of that is going to be dividing x by 3. So I'm actually going to show you how to find these in the next slide. So the way to find an inverse function of your original function is to interchange every x and y. I'm going to start with a graph, but actually most of the ones that you're going to get, you're going to do using algebra. So after the graphing one, we'll do one by hand. So number one, the first one I have is, I'm going to call it f of x. In order to find the inverse of this, you are going to interchange all of your x and y values. So this point I have on the vertex is at 1, 0. This one is at 2, 1. And I also have one at 0, 1. So just for the sake of this one, I'm going to show you like the exact way that we're going to do it. So first of all, my first point is at 2, 1. What that means is that my inverse function, which I'm going to do in green, is going to have a point at 1, 2, which is right here. Also, my original point is, my original vertex is at 1, 0. My new vertex is at 0, 1. And I had a y-intercept at 0, 1. Actually, that's going to become an x-intercept, and it's going to become at 1, 0. You can do the same with a few other points. So I have this one over here looks like it's at negative 1, 3. I'm now going to have one at 3, negative 1. And it looks like I have one over here around, I'm going to say, I think it's probably at 3, 3. That's probably not perfect. That one actually, since the x and the y are the same, that one's also going to stay the same. But what's going to happen is this entire thing is going to be a similar graph, except that it's going to be kind of shifted around. So this one in green, I write as f inverse of x. So the key way to get from a normal function to its inverse is by interchanging all of your x and y values. So now let's do an example by hand. These are the ones that you're going to be doing the most in class. So my first example is f of x equals 8x. So whenever I start these problems out, I always start by rewriting the f of x as just a y. It just makes things a lot more simple. So I just like to start it by writing something like y equals 8x. The next step that you're going to do is kind of confusing one, but here's where you're going to interchange your x and y. So what's going to happen now is my function is now going to be written as x equals 8y. From there, you need to solve for y. In order to solve for y, you divide both sides by 8. When you do that, you get y equals x over 8. The last thing is you're going to want to rewrite it as an inverse. So you're going to rewrite it, and you're going to use the notation I used on the last problem, which is f inverse of x. Looks like it's f to the negative 1. So your final answer is going to be f inverse of x equals x over 8. So your y becomes f inverse of x. This one, you can see that it kind of makes sense because the original function has multiplying by 8, the inverse has dividing by 8. So let's do a few more. So for number 2, I would like you, if you feel like you can do it, you can work this out on your own. If you are still not sure, feel free to just watch me do it. So my first step is going to be to rewrite the f of x as y equals something. From there, I have to interchange my x and my y. I get x equals 4y minus 1. The next thing I need to do is solve for y. I do that by moving over my 1, which gives me x plus 1 equals 4y, followed by dividing both sides by 4. I get y equals x plus 1 over 4, or f inverse of x equals x plus 1 over 4. This is my final answer. So I'm going to give you one more. Let's say we have f of x equals x to the second power minus 3. This one is a little bit harder because of the x squared. However, we can still do it. Your first step is going to be to rewrite it as y equals x squared minus 3. And from there, you need to remember that you're going to interchange your x and your y. So that's going to change it to x equals y squared minus 3. From there, we have to solve for y. So we're going to start by moving over the 3. And when you have y squared equals something, in order to undo the y squared, you need to take the square root of both sides. That's the first thing. However, the rule is when you take the square root of both sides, you also need to add a plus or minus. So I will actually get y equals plus or minus the square root of x plus 3. And my final answer is going to be written as f of negative 1, f to f inverse of x is going to be plus or minus the square root of x plus 3. The next thing that we're going to do with inverses involves a little rule. So my rule is that when two functions are inverses, if you take their compositions in both directions, you will end up with x. So this rule is a little bit confusing until you actually do one. So I'll show you an example. For my examples here, I would like you to verify that the two functions are inverses. And when I ask you to verify, sometimes I'm going to ask you to prove that the following are inverses. That means the same thing. But in order to verify that two things are inverses, you need to check their compositions, and from there you can figure it out. So for example, let's say I have f of x equals 7x plus 4 and g of x equals x minus 4 over 7. In order to verify that these two things are inverses, I have to check their compositions. I am going to start with f of g of x. I actually don't care what you start with. If you want to do g of f of x, that's fine too. You need to do both of them. And when we do these, we should get x in the end. That's what we're hoping for. So f of g of x would be written as f of x minus 4 over 7. And I'm going to substitute this stuff in here into the x in the other equation. So I'm going to get 7 times x minus 4 over 7 plus 4. So for this next part, there's several ways to do it. In my opinion, the easiest way to deal with this problem is to cancel out your 7s, and you're just left with x minus 4 plus 4, which gives you x. So we're halfway there. We know that we got x for the first one. we are hoping that now we get x for the second one. So now what I'm going to do is I do g of f of x, which is g of 7x plus 4. I'm going to take this 7x plus 4 and plug it into the x in the g equation. When I do that, I get 7x plus 4 minus 4 over 7. That gives me 7x plus 0 over 7. 7x over 7 is just going to give me x. So I'm okay there too. Now you can say something like, yes, they are inverses. The next problem looks a little weird. So we want to verify that these are inverses. The reason that it looks weird is because we actually have a domain given for the first one, for f of x. And the purpose of that is so that we don't have to worry about plus or minus. If you look back at problem number 3, when we found the inverse of something with x squared, we did end up with a plus or minus square root. If you just have x's only things that are 0 or positive, x is greater than or equal to 0, then you don't have to deal with the plus or minus. So that's the purpose of that. If it confuses you and you find it weird, you actually can just ignore it for the sake of this problem. And I just noticed a mistake. This should be actually x minus 1 under the square root. So if you feel like you know what to do, feel free to pause and try it. Otherwise, just watch carefully when I go through it. First thing I'm going to do is I'm going to compute f of g of x. When I do that, that's the same thing as f of the square root of x minus 1. So now what I need to do is I need to take this x minus 1, substitute it into the x in the f equation. That is going to give me the square root of x minus 1, and I'm going to do that squared plus 1. This one looks super hard because you have like a square root, you have it squared, but actually all you need to do is remember that when you have a square root and you're squaring it, you just end up with whatever's under the square root. That gives us x minus 1 here. Then we do plus 1. And then x minus 1 plus 1 is actually just going to give us x. So we're halfway there. Now you need to do the same thing, but you have to do g of f of x. So f of x is x squared plus 1. You can ignore that x is greater than or equal to 0 for now. That's not going to make much of a difference in the end. So we have g of x squared plus 1. We're going to substitute the x squared plus 1 into the x in the g equation. So we end up putting in x squared plus 1. Don't forget to put in that other minus 1. So this is going to end up giving us actually just x squared plus 0, or just x squared. And the square root of x squared is very nicely going to only give us just an x. So that's my answer. And because I got an x for both of these, I'm going to say that f of x and g of x are inverses.